Hello everyone, welcome back. This is Mr. Kalab from Complete Chemistry by Kalab. This is part 2 for the Cambridge International ACE and A-Level Advanced Practical Skills 1, question number 2. In this video, we're going to focus on solving the questions for the practical problem in question number 2. Now, this is the question. Here we have sodium sulfites is oxidized when it reacts with excess iodine. So one thing to focus here is the fact that iodine is in excess, okay? Iodine is in excess. What does this mean? After the reaction proceeds, there is some amount of iodine, there will be some amount of iodine left unreacted, okay? So this remaining iodine will be or can be titrated using aqueous sodium thiosulfates as given in this equation. So iodine can be reacted with sodium thiosulfates to form these two products, okay? So in this experiment, our main goal is to determine the integer value of X, okay, in the formula of hydrated sodium sulfite. In this formula, we're expected to determine the value of X. So you remember the practical work. So let's move to the calculations now. So the first thing we need to do is we need to draw a table to record our volumes for the rough titration. Okay, what we need to do is we need to have our final volume in centimeter cubes, initial volume in centimeter cubes, and then rough titer. Rough titer in centimeter cube, of course. So as you can remember from the last video, the final volume for the rough titer was around 21.00. The initial was 0.00, meaning our rough titer, meaning the difference between these two numbers, would be 21.00 centimeter cubes. Okay, the next thing here is to construct a table to record your accurate titrations. Okay, we're going to do the same now. So the first thing we need to write is accurate titrations here. Accurate titrations. And then let's assume that we have performed 3 accurate titrations. 2, 3, and we'll have our final volume in centimeter cube again, initial volume in centimeter cube again, and then volume of Fa4 used. In centimeter cube, and then we need to add another column, which is selected titers. Selected titers. Okay. Now this table will be used to record our data for the accurate titrations. Okay. So for the first titer, the data was 30.20. The final volume was 30.20. The initial was 10.00, and then the difference would be 20.20. Okay, so the data collected was like this, and then let's select our concordant titers. Okay, so what does it mean by concordant titer? If the difference between the two recorded volumes or the titers is at most 0.1. Okay, if the difference is below 0.1 centimeter cubes, we can select them as concordant titers. So in this experiment, our concordant titers are the first and second titers. So this table here is for the examiners. So they will give you 7 marks for these two tables. Okay, the first mark goes to calculating your rough titer. So final volume, initial volume, and then rough titer. Doing this will get you 1 mark. Okay, the second mark goes to labeling or labeling centimeter cubes to the volume readings. Okay, so for saying this, and this, you'll get another 1 mark. For completing this this table for recording all this data in the table. You will get another third mark, and then for selecting your accurate titers or your concordant titers, you will get this mark. But these 3 marks, the fifth, sixth, and 7 marks are for your accuracy. What does accuracy mean? If the difference between your titer and the supervisor's titer is less than or equal to 0.6, you get the fifth mark. And then if the difference between your titer and the supervisor's titer is less than 0.4, you get the 6th mark. If the difference is less than or equal to 0.2, you get the 7th mark. Okay, if your difference with the supervisor is 0.2 or less, you get 7 of these marks. Good. Now let's move to the calculations. The first question is to calculate the suitable mean value to use in your calculations. Okay, mean value of the volume. So what do? We come to the table. We have selected 2 titers here. We're going to calculate the mean value of these 2 titers. Okay, so this would be 20.20 plus 20.25. We're going to take the mean. We're going to divide this by 2. So this would be around 20.225. 20.225 centimeter cubes. So we're done with B. Now let's move to C. So C1 is your for appropriate number of significant figures to your answers in C2, C3, and C4 and C5. Okay, so make sure to pay attention to your significant figures. This will get you 1 mark. Okay, C2 calculates the amount in mole of sodium thiosulfates present in the volume of Fa4 in B. Volume of Fa4 in B. So how do we calculate moles? How do we calculate moles? We have mass of sodium thiosulfates, which is mass of sodium thiosulfates is given by 14.24 grams. So we're going to use this mass. So do you guys remember this? Mole is equal to mass over molar mass. So now we have the mole. We can do molar mass of sodium thiosulfate and then calculate the mole. Okay. So this would be 14.24 divided by the molar mass of sodium thiosulfate, which is 158.2. Okay, most of you would guess the calculation is done here, but it's not. Another keyword is here. Okay, it says moles of thiosulfate present in the volume of Fa4 in B. What is the volume of Fa4 in B? So Fa4 in B was our mean titrate, which is 20.225. Okay, but we know that Fa4 was calculated or was prepared in 100 centimeter cubes. So what we're going to do is we're going to multiply this by 20.225 divided by 1000. Okay, good. Now this will be 0.00182. 0.00182 moles of sodium thiosulfate. How many significant figures? 1, 2, 3 significant figures. Now we have 3 significant figures. Good. The next question is to calculate the amount in mole of iodine in 1 decimeter cube of Fa5. Amount in mole of iodine in 1 decimeter cube of Fa5. So what we're going to do is we're going to look at the equation relating iodine and sodium thiosulfate. Okay, there we'll find the mole ratio of these two. So this is the equation here. 1 mole of iodine requires 2 moles of thiosulfate. So this is 1:2. Good. So moles of iodine will be 0.00182 divided by 2, as the ratio is 1:2. Okay, but the calculation is not done here again. We're asked to calculate moles of iodine in 1 decimeter cube of Fa5. In 1 decimeter cube of Fa5, which is in 100 centimeter cubes. We're going to divide this by 25 because Fa5 used in our reaction was 25 centimeter cubes. Okay, if this number 20.25 centimeter cube of Fa4 is for every 25 centimeter cube of Fa5. But now we're asked to determine the mole of iodine in 1 decimeter cube. So if 0.0182 divided by 2 is for 25 centimeter cubes, to find the mole in 1000, I use this relation or proportion, okay? So this would be 0.0364. 0.0364 moles of iodine. Again, 3 significant figures. Good. In C4, we're asked to use the information given and our answer in C3 to calculate the amount in mole of iodine that is reacted with sodium sulfite, sulfite when Fa5 was prepared. So now we're asking a question to determine the amount in mole of iodine reacted. We have to know the total amount of iodine, and then we have to deduct the excess amount, okay? Total minus excess would be the amount of iodine reacted. Okay, now let's calculate the total amount of iodine. How do we calculate total amount of iodine? We go back to the step where it shows the preparation of Fa5. So it says Fa5 was prepared by mixing 5 grams of hydrated sodium sulfite when it is added to 600 centimeter cube of 0.1 mole per decimeter cube of aqueous iodine. What does this mean? Mole of iodine from this would be concentration times the volume. Concentration is 0.100 times the volume is 600 centimeter cubes. Let's convert it into decimeter cubes by dividing it by 1000. So moles of iodine, or the total moles of iodine, would be 0.1 times 600 over 1000, which will be 0.06 moles. This is moles of iodine. Moles of iodine originally present in our sample. So this would be 0.06 minus amount of iodine in excess, which is going to be this value. So how is this going to be this value? Why, to begin with, we did the titration to determine the amount of iodine left unreacted, because the question starts by indicating that iodine was in excess. Okay, so to determine the amount of iodine that is left unreacted, we did the titration. So this amount is basically amount of iodine left unreacted. So 0.06 minus 0.0364. This would be this would be the value for moles of iodine that are reacted. Okay, 0.0236. 0.0236 moles of iodine. Now we're in C5. C5 asks us to use our answer in C4 to calculate the relative formula mass, or MR, for dehydrated sodium sulfites. So how do we calculate MR, or molar mass? We need to remember the formula for mole. N equals mass over molar mass. So how do we calculate molar mass? Molar mass would be mass over moles, okay? So where do we find the mass? Mass of sodium sulfites was given in the step where it shows the preparation of Fa5. So it says 5 grams of hydrated sodium sulfite is added. So mass of sodium sulfite is 5 grams. Okay, this is 5.0 grams divided by what's mole of sodium, the hydrated sodium sulfite. Where do we get mole of sodium sulfite? Let's go back to our equations. Equation 1 shows us the reaction of sodium sulfite and iodine. So as you can see, 1 mole of sodium sulfite is being added to 1 mole of iodine. So they are in 1:1 ratio. What does this mean? We can use moles of iodine reacted as moles of sodium sulfite reacted, as they are 1:1 ratio. So this would be 5.0 divided by 0.0236. Okay, now this would be 200 and 11.86. This is molar mass for the hydrated sodium sulfite. Now we're supposed to, or we're expected to calculate the integer value of x from this. Now this is easy because we have the molar mass. What is MR? MR is 211.86. What does this mean? This number is the same as this and this. We have to add these two to get this number. So 211.86 is equal to what is molar mass of sodium sulfite? We need to calculate molar mass of sodium sulfite separately. This would be around 126.1. 126.1 plus we have x moles of H2O. What is the mass of 1 mole of H2O? It's going to be 18. So we have 18x here. Now let's solve for x. So 18x will be equal with 211.86 minus 126.1. So 18x is the same as 85.76 over 18 over 18. Now the value of x would be 85.76 divided by 1/8. This would be 4.76. Now remember, we were asked to calculate the integer value of x. What does that mean? We have to round it to the nearest integer. This would be 5. So this is how you get your 14 marks from this question. So remember that stoichiometry, water of crystallization, they always appear in your exams. So make sure you are able to do stoichiometry calculations to calculate water of crystallization. Thank you for following. Thank you for liking this video. If you have any comments, please don't hesitate to write them. And then if there is any topic that you want me to cover, please comment the topic. Thank you again.